So we want to find which binomials are factors. So according to the factor theorem, what we're trying to find, say in A, is we're wondering, if I call this P of x, is P of negative 1 equal to 0? If it is, then we can say, yes, x plus 1 is a factor. If it isn't, we would say, no, it is not a factor. So we plug in negative 1. What happens to a negative 1 when it gets cubed? It's going to stay negative, right? And what's going to happen when a negative gets squared? That one becomes positive, so that sign won't change. The next one will change. So P of negative 1 will equal a negative 1 minus a 6 minus a 5 plus a 12. It's equal to 0, which means that x plus 1 is a factor. So see how the remainder theorem, plugging in minus 1, works really quick with a plus 1 or a minus 1? That was really easy mental math. Now, when we get to B, now we'd have to be plugging in 3. So at that point, I might say, you know what? I think I'd rather use synthetic division than plugging in a 3, just because the mental math might get a little bit large. So in part B, I decide I'd rather use synthetic division. So 1 minus 6, 5, 12. They were already written in the correct order. My highest power is an x cubed, and I have 4 numbers, so that means I'm not missing any. I'll put a 3 on the outside, opposite of the x minus 3. Bring down the 1. And again, the remainder is 0. So the factor theorem says, since the remainder is 0, x minus 3 is a factor. So the factor theorem says if we ever get a remainder of 0, that means that that thing is a factor. Part C. Again, once we're getting to 4s, I think for sure that synthetic division will be faster than plugging it in. So bring down the 1. And we find out that x minus 4 is also a factor. Find out, are all of these factors? So the last one was x plus 4. No. So since the remainder is not 0, x minus 4 is not a factor. So what did we discover? We discovered 3 factors by doing A, B, C, and we discovered the 4th one, D, wasn't a factor. Now, we could have known already that the fourth one wasn't going to be a factor because this is an x cubed.
You're done. X minus 4 is not a factor.
X plus 4, thank you. There we go. Good. If you have an x cubed, you can have at most 3 factors. Just like when we were factoring quadratics, that's the main thing you factored up till now with x squared, you can have at most 2 factors. Some of them can't be factored, but if you can factor them, you will get at least 2 factors, or at most 2 factors. And with x cubed, the same thing is true. You can get at most 3 factors. And x to the 4, you could get at most 4 factors, x to the 5 at most 5 factors, and so on. So if we write our division statement here, we just found out so we have factored this completely because we found out all 3 factors. Now, they were given to us and we tried each one with the factor theorem and found out that 3 of them, the remainder was 0, so 3 of them were factors. So that's how we were able to factor this. But what's going to happen is you're not going to just try random ones until you find 3 of them that worked. Did I do it again? Oh my goodness. Is it Monday? I haven't even had that much chocolate yet. Okay, good. What we're going to find is you're just going to try to find that first one. You're going to try to find 1 factor. So let's say you found out your first factor was with the minus, let's just move it up here a little bit. Let's say you found x minus 4 was your first factor. And you found it using synthetic division just like we did here. So we could write the division statement after this point. I'm going to erase this one that's not a factor just to give us some more space. And our division statement would be x cubed minus 6x squared plus 5x plus 12 equals, we know that x minus 4 is a factor, and we get x squared minus 2x minus 3 when we're left. And if this question asked us to factor completely, you wouldn't go back to plugging in numbers into the long division because you've now simplified it. You now know that it's x minus 4 here, and this is a quadratic. So at this point, you could say, well, how do I factor x squared minus 2x minus 3? Has to be an x and an x. Has to be a 1 and a 3. Outside has to be negative. Inside has to be positive. And we get the same list of factors that we listed at the end anyways. Just going to move up to B. If you had found this, that means you would have had x minus 3, and here you'd have x squared minus 3x minus 4. Can you see when you factor this, you're going to get x plus 1, x minus 4. You'll get the same list of factors no matter which one you start with. So the key thing is finding that first one. How do we find that first one? What are possible factors? Okay? Now, to do that, I'm getting a little bit ahead, but so this is a good example to do that in. Let's say I was getting you to factor x squared minus 2x minus 3. Why didn't I start with, maybe it's x plus 7 times something? Why is that such a bad choice to start with? If I'm trying to factor x squared minus 2x minus 3, why would I not start with an x plus 7? It's higher than all the values. What do we know about these last numbers here and here? Those last numbers have to multiply to get the minus 3. 7 is a very bad choice in that regard. In fact, 3 is a really easy one because you know it only can be 1 and 3. It's a really simple idea. Now, that idea extends even when you get to larger polynomials. What number do we have here? 12. What are our last numbers? They're 1, -3, and -4. What's 1 times -3 times -4? 12. Okay? So this last number is going to give us a hint as to what might be possible. You will never get a number in one of your factors that isn't a factor of 12. So the only possibilities are 1, 2, 3, 4, 6, and 12, which are a lot of possibilities. But when you've got your factor theorem, it doesn't take too long before you find one that works, and then we can go from there. Okay, questions from this one? (10), 8, and 12. And I want to make sure you try 12.